Is it visible? Screen?
Yes, sir.
We are going to discuss here today regular false method. Or in between, I will tell you another method also along with this. Looks like same. That is also simultaneously I will discuss what is the difference. Nicely, you should pick it up. Okay. Second method. That is not actually oblique. This is end. बोलो. Any query? Is it visible?
Yes, sir.
Or am I audible?
Yes, sir. Yes, sir.
So, if you will get trouble in understanding in between, instantly you should ask. Okay. So in bisection method also, for the two initial condition x0, x1 in between that 2 points, you are finding that 2 points. In between that 2 points, graph is cutting the x-axis, and then you will step by step bisect that interval, and step by step you are finding a small teeny sub interval. Process is here also same, looks like same, but it is in this process, after getting the interval, it is not middle point. It is other than middle point, and that is the method. Okay, in bisection method, it was middle point. Here, it is not middle point, other than middle point, some other point. That point calculation is the method here. Okay, and in Newtonian method also, you need that idea of 2 points where the graph is cutting the x-axis. Suppose you are finding some specific route, so you need that 2 points such that you can able to choose a single initial condition for the Newton-Raphson method. Here it is the hybrid method combination of that two methods. It is iteration as well as not intersection. Actually, after getting that interval, still reducing that interval, not simply by cutting the middle point. Other than middle point, some other point. Suppose, let me check. Actually, initially your equation is whatever f of x equals to 0 is given, and from here you have to calculate target is. Here is also better approximate solution. That is the target, and in the solution process, what we will do here, we will pick up any 2 points. Suppose x0 1 point and x1 another point, such that in these 2 points your graph is cutting the x-axis. Means functional value, if I will check in these 2 points, functional value, their sign will be opposite, means less than 0. Okay, up to that much work you can able to do. Means graph will be looks like this type of thing. Suppose x0 is here, x1 is here, and in between that 2 points graph is, since graph is continuous, fx is continuous, so obviously it will be looks like this, or looks like this, whatever, or looks like whatever this, whatever it is, it will cut at least x-axis once. Okay, such that In one point functional value positive, in another point functional value negative, their product less than 0. So that is the process. Okay, now in this method, bisection method, simply after getting the 2 points, we are calculating the middle point. Middle point is x0 plus x1 by 2. Other than middle points, what we will do here, that is, you just nicely watch. Okay, let me again try to draw this graph nicely. Let me check. This is the x0 and this is the x1. In between x0 to x1, it is cutting the x-axis, and that is, I am telling you, it is not middle point. Actually, it is not middle point. This is the, if I try to write the graph, looks like this. So in x1 it is positive, x1 it is positive, in x0 it is negative functional value. So f of x0 star f of x1 less than 0, and initially you have chosen x0 and x1 initial condition such that. Now what we are doing here in this point, where I am trying to draw a vertical line where it will touch the graph from that point, and from x1 also where it will touch the graph. In these 2 points, I am trying to draw a vertical line where these graphs will, where this vertical line touch the graph. In that 2 points, I am trying to draw a joining chord. Suppose that chord is looks like this. Okay, and that chord is where it will cut the x-axis. That is my updated point, and that updated point I rename as x2. X2 is not here middle point. So can you able to tell me, can you able to calculate that x2 with the help of x0, x1, f, and this graph is the fx. In bisection method, x2 was there. X2 is the middle point. X2 is x0 plus x1, and simply middle points. You are not drawing there the chord. Here you are trying to draw a chord where that chord is cutting the x-axis. That is the updated point. Okay, are you listening?
Yes,
Students?
sir.
Yes, sir.
Okay. Now logic is, can you able to calculate x2 with the help of x0 and x1? These two things known. So you may able to calculate f of x0. You may able to calculate f of x1. So you just try to find out the triangle similar property. This triangle is the right angle triangle, isn't it? And this triangle is also right angle triangle. Okay, so from triangle similar property, suppose I am trying to, suppose this chord is A to B. I am trying to write two chords, two triangle, right angle triangle. Suppose triangle x0, x2, and A triangle, and another triangle x2, x1, and B. Is these two triangles are similar? Both are right angle triangle. Are
Yes.
similar triangle, isn't it?
Yes.
So for the similar triangle, we can able to compare the base by base, base height by base equals to height by base for both triangles.
Yes, sir.
So you just tell me, for this right angle triangle, what is the height? If I will write height x0 to A by base, and this base is this, This means x0, x2. X2, its numerical value will be different actually, and its height is x1b by x2, x1. Tell me the values. X0 to x0, suppose this is x0, x0 to x, that height is, what is the height? F of x0, isn't it?
Yes, sir.
By x0 to x2 distance, what is the distance? Origin to this much, origin to this much x2, origin to this much x0. So x2 minus x0. Is it clear? And x1 to b, f of x1. X1 to b, this height is f of x1. You should tell me if you will get trouble in understanding. Okay. And x2 to x1, what is the distance? x2 to x1. Bolo.
x1 minus x2.
x1 minus x2. Now tell me, this comparison is will be equal. For the similar triangle, we have done the right things here. That is my query. Actually, you can able to compare two triangles. Suppose this right angle triangle, and along with this right angle triangle. These two triangles you may compare. Its height by base equals to its heights by base. Okay. Whatever, but their faces should be in same side. So suppose if I will rotate this right angle triangle here, if it would be looks like this, then I can able to compare this right angle triangle and this right angle triangle. All the triangle similar property will be same. As we know, like the ratio property will be equal. Okay, but you just see this is in opposite sides. So if I will check its height for this triangle, its height f of x0, its numerical value will be the negative. You just see graph is lying below of the x-axis, its numerical value negative, but its numerical value positive. So if I will compare the triangle similar property, I have to put here a negative sign. Are you getting my point? What I am trying to do? If triangles are in same, their faces are in same direction, then you may able to use simply the ratio property. Okay, since it is in opposite direction, its face is in opposite direction, and numerical value also you are seeing that f of x0 is negative. Its numerical value, heights numerical value positive. So to compare this angle similar property, I have to put here negative sign, such that it is also will be positive and this is also positive. Is it clear?
Yes, sir. Yes, sir.
Okay. Now this comparison is okay, no problem. Now you just try to calculate. Actually, in this relation, initially you have picked up x0, x1, and you can able to calculate f of x0, f of x1. That is already known. Simply one thing is unknown, where the chord is cutting the x-axis, that x2. So from this relationship, you just try to calculate x2. Bring x to left hand side and try to write everything right hand side. So x2, if I will write left hand side and remaining all the terms right hand side, it will be x0 f of x1 minus x1 f of x0 by, you just try to calculate it, it will come f of x1 minus f of x0. Okay,
Yes, sir.
calculation is okay. Actually, in bisection method, same thing was there in place of x2. It is not middle point in bisection method. It was middle point. X2 you were calculating there. X2 is x0 plus x1 by 2. Other than calculating the middle point, you are calculating another point in between point x0 to x1, x2. That point is calculated by this formula. After getting that point, as well as the bisection method, what you have done there, same work you have to do here also. Okay. In bisection method, it was middle point, but it is not middle point. With the help of this formula, you have to calculate. And after getting that points, you have to update the interval. This interval you will pick up, or this interval you will pick up. In which interval graph will cut the x-axis. Okay, can you able to do that logic? So for that purpose, what we will do in x2, you will check the functional sign. Isn't it? And you will compare its functional sign along with the x0 functional sign, or along with f of x1 functional sign, which is opposite. That subinterval I will pick up, another subinterval I will neglect. That logic you have to put here. So after that, what we will do, I will check the functional sign at x2. So, and I will check along with f of x0 it is opposite, or along with f of x1 it is opposite. That subinterval I will pick up, because within that subinterval graph is cutting the x-axis. Another subinterval I will cancel, because in that subinterval graph is lying same side of the x-axis. So, is it clear what I am trying to tell you?
Yes, sir.
That is, after that the process looks like bisection method. Okay, so let me check what I am doing here. Okay, if f of x2, you are calculating at x2 functional sign and comparing along with the f of x0. Let me say this is less than 0, means, okay, in this graph it is not less than 0. In this graph it is not less than 0, because f of x0 negative, at x2 functional sign is also negative, isn't it? So in this case it is not positive, both negative, so their product is positive. So anyhow, suppose this is negative, then you will select this subinterval. Okay, x0 to x2, that subinterval you will select. For that purpose, you just keep unchanged lower boundary point by lower boundary point, means simply x0 will be x0 unchanged, but what is the x2 you got, that will be replaced by upper boundary. Whatever the x2 you got, that will be replaced by our upper boundary. So again you will rename by x0 and x1 again and again. Okay, after calculating the some updated point, that will be replaced by upper boundary or lower boundary point, and I am getting a small subinterval again and again. If this condition happens, this else, but in this graph you just see this condition is not happening here. So what you have to do? Another subinterval you have to pick up. This is you have to cancel. So else x2 will be lower boundary point. Then x2 will be lower boundary point, means x2 is replaced by x0 and x1 will be unchanged. In that process, your from original x0 to x1 interval, it is replaced by smaller subinterval, suppose x0 to x1, this one. Again, with the help of same formula, x0, x1 updated, again you just calculate x2, again with the help of this formula, Okay, and that x2 calculation will come. Again you will check sign there. Again you just reduce that subinterval step by step. Your interval is reducing in such a way it will be looks like a teeny, so small, looks like a point, such that within that point graph is crossing the x-axis. That time, suppose your points is looks like, suppose as for example I am trying to take one interval I am trying to draw here. That interval lower boundary is suppose 2.1579 and another upper boundary is 2.158. Can you able to see these subintervals are so teeny? So that time you will see, or you can able to write root is approximately f2.15 or 2.16. Okay, means if you have understood the bisection method, then after calculating x2 calculation was there simply middle point. X2 you were calculating there with the help of x0 and x1 such that x0 plus x1 by 2. In that way, means that formula was simply x0 plus x1 by 2 in bisection method. But other than this, you have to calculate x2 means updated point with the help of this formula. After getting that point, again you just check the functional sign along with which boundary point functional value opposite in sign. On that basis, that sub interval you are pick up. Okay, and this process will be repeated within a loop. Do while loop we have used there by putting a epsilon condition or error condition such that it will be continue on the basis of question how much decimal places it will be asked to you. You just continue this process. So repeat process of x2 calculus. Up to desired degree of accuracy match. Means step by step you are calculating x2 middle point such that in that step by step calculation of x2 in every step is representing the iteration in two consecutive iteration. Desired degree of accuracy means on the basis of question, suppose it is asking you write down the answer up to 2 decimal place. So in two consecutive iteration up to 2 decimal places, x2 value calculation is matched. Then you will stop your iteration. So this method is superior than bisection method. Its rate of convergence, I am not exactly able to say. It looks like 1.53 or 56 like that, but 1.5 at least 1.5 you may consider. Okay, superior than bisection method means little advanced than bisection.
Excuse me, sir.
Bolo.
Sir, is it not something like a binary search?
Binary search.
Concept that we saying binary search also we just shift elements if it is not found at the middle or just shifting same way we are thinking.
It is Binary, what you told? Binary search or what?
So there was a concept in binary search regarding the shifting of elements if it is not found in the middle.
Oh, actually, you may rename again and again without renaming lots of variable, without creating lots of variable. After getting that point, I am trying to shifting that point. It will be upper boundary point or lower boundary point, nothing else. If I will consider this subinterval, it will be lower boundary. If I will consider this subinterval, it will be upper boundary or
Yes.
nothing else. Looks like that. After getting means again, actually our original work started from x0 and x1. So I need x0 and x1 again and again. But in every iteration, our length of the interval is reducing. In next time it is reducing this much, next time it is reducing this much, next time it is this much, next time this much, the next time this much. At the last, its interval length is so teeny. I am telling you, suppose looks like that type of example. That time it will looks like if you will try to draw that 2 points, you cannot able to manually plot. Okay, it is looks like a point. Then you can able to say approximately solution is looks like this. So it is looks like shifting again and again. You are shifting the calculated point as a upper boundary point or lower boundary point. Your work is simply doing in between. Your length of the interval is reducing by cutting or neglecting some portion.
Got it.
So I think you can able to do this. This is
Yes,
not.
sir.
This is known as regular false method. Okay. For the time being, I would like to express another method, what I told you, secant method. Nicely, you just try to see and watch what is the difference. Okay. Up to this much is okay. X2 calculation. X2 calculation is okay. After getting X2, okay, in secant method I will not check the functional sign, it's positive or negative, along with f of x0 and f of x1. I will not compare. Simply, I will think with the help of x0 and x1, x2 is the updated point. After getting x2 updated point with the help of x1 and x2, I will get next updated point. After getting step by step in that iteration process, I will keep continue. So what is that iteration process? Suppose with the help of x0 and x1 you have got x2. Again you will just try to draw a vertical line in x2. Okay, and from x2, that touching point where the graph is, where the graph vertical line touch the graph, that point to opposite end point, you just try to draw another chord, and that chord is you just rename by next updated point x3. So you just see this triangle, and this triangle is right angle triangle again. If I will use the right angle triangle property here is also with the help of these two triangles, this one and this one. So with the help of x1 and x2, we can able to calculate x3. So x3 will come as x1 f of, by watching this formula. Any query?
No, sir.
Somebody's mic on. Okay. If you are not asking me anything, you just off your mic. Okay. When you will ask me, simply on that time, you just open your mic. Okay, by watching this formula x2 you are calculating with the help of x0 and x1. The formula was there, looks like this. So now we will calculate x3 with the help of x1 and x2. So by watching the same type of triangle, similar property we have used, looks like that. Okay, for these two triangles. So I will get here x1 f of x2 minus x2 f of x1 by f of x2 minus f of x1. Okay. So after getting x3, again I will try to draw a vertical line here at x3 where it will touch the graph. From that point to opposite end point I will try to draw a chord where it will cut the x-axis, that is the next updated point, that is the x4. These joining chord where it will cut the x-axis, these points are updated point, that points are approaching towards the point where the graph is cutting the x-axis. Logic is that, like Newton-Raphson method. So this is the step-by-step process of iteration. In every iteration, you are getting the updated point, that points are approaching towards the point where the solution exists, means graph is cutting the x-axis. So again, with the help of x2 and x3, we will get x4. So x4 will be x2 f of x3, x3 f of x4 by, sorry, this is x2 f of x3 minus f of x2. So these are the process of, this is the first iteration, second iteration, third iteration. In this step by step iteration process, you are approaching towards the solution where the graph is cutting the x-axis. So initially you have to pick up 2 points x0 and x1. With the help of x0, x1 you will get x2 by this formula. After getting that x2, with the help of x1 and x2 you will get x3. Same formula structure we have used. After getting x2, x3 we will get x4 with the help of x2 and x3. With the help of this formula, again we may able to calculate x5 with the help of x3, x4, x5, x6, x7, like that. These are the step-by-step iteration. So in that process, you may able to write a iteration scheme here. That is the nth iteration will be with the help of previous 2 points, x n plus 1 will be, follow, x n minus 1 f of x n minus x n f of x n minus 1 by f of x n minus f of x n minus 1. So that iteration or recurrence relation formula you have to calculate within the loop, and within the loop you will give the condition of breaking the loop such that in 2 consecutive iteration up to desired degree of accuracy match, means iterated values, then you will break the loop and you will print the result. That is known as the secant method. So there is not too much difference. Okay. In regular Fels method, step by step updated value, I am checking the functional side and I am replacing by upper boundary or lower boundary point. Without doing that, simply we are telling that is the updated value. With the help of that updated value, next updated value, means process is same. Always the chord is cutting the x-axis, that points are approaching towards the point where the graph is cutting the x-axis. That is the idea. Two methods is clear.
Yes, sir.
Okay, try to study these two methods nicely, and next day we will try to practice some numerical example on these two methods simultaneously, I think.
Excuse me,
And
sir.
bolo.
Sir, in second method, we will check sign of fx2 also.
Actually, in next iteration, actually for this type of updatation, you don't need, but to calculate in the next iteration, you need f of x2. But its sign is not important. It can be positive or negative, that doesn't matter. But next step calculation, you need that functional value, isn't it?
Yes, okay, sir.
Because whatever the updated value, its functional value, obviously you need to calculate the next updated value. But its sign is not important in this second method. Its sign important in regular false method. To update that value, it will be upper boundary point or lower boundary point.
Okay, sir.
Or any query? In regular false method, I told you it is the superior than bisection method. That is the advantage. If it will be asked to you, rate of convergence, you should write 1.56 or approximately 1.6 or regular false method always converge. Always you will get solution. But secant method may not converge sometimes. Means if in two consecutive iteration, I am writing here in logic, in two consecutive iterations, suppose f of xn plus 1, that is the iterated root solution, that will be nearby 0, isn't it? If it is equals to previous iterated value, functional value, means obviously will approximate or write the solution is the nth iterated or xn plus 1th iterated value. But this is not giving you approximate 0. It is not giving you looks like 0 solution. Then method is not converged. And if it is approximately 0, then converge. Converge means you will get the solution. And that time you will approximate solution is, you may write this one or this one. You got idea?
Yes, sir.
Means in two consecutive iterations, suppose in some examples, suppose you will get in after doing some iteration, iterated values are matched. In two consecutive iteration, you are getting matching result, as well as the functional value is also becoming the same, but that is not becoming 0. That is not becoming, so method is not converged. If it is giving you looks like 0 solution, obviously, suppose f of x equals to 0, you are getting a solution x equals to say a is solution, then f of a equals to 0. That is the logic, mathematical logic. So whatever the solution you are trying to get, if it is better approximate solution, it is giving you better almost 0 looks like that. Okay, if it is not giving you 0, means this method is not converged. Or any other query? So in this module, I think you understood 4 method: bisection method, Newton-Raphson method, regular false method, and secant method. Okay. So in every method, what is the plus point, minus point, when it is applicable, when it is not applicable. Okay. Bisection method and regular Folsey method always give you the solution. Newton-Raphson method and secant method, sometimes it is not converged. That idea you have to nicely study or keep the points in your mind. Okay. Or in every method's rate of convergence, and try to understand what is the condition of convergence for these methods, and geometrically or in which way we have established the formula. That idea also will be in your mind to solve the problems. Okay. Or any other query?
No, sir.
No, sir.
Okay, then next we will solve some numerical examples. So if you don't have any query, then we are ending the meeting. So we are ending the meeting. Okay.
Yes, sir.
Thank you, sir.
Thank you.
Thank you,
Thank
sir.
you, sir.